Hi guys. So you know, uh, I'm back with a different video this time, and I've actually had this for a long time, but I just didn't get the time to sort of equip this in a way where I can present it. But the idea for today's video was that we will be sort of doing some RBD simulation, and we're going to be doing it in a way where we can blend it uh, in a way where we have control over what parts were breaking and what parts were not breaking. So uh, in all, we're trying to art direct the way we break something. Now, in this case, uh, and this is actually from an older project that I had, and what the original idea was to sort of break this tube cylinder and expose uh, this. Wait, let me just. Yeah, and expose this plate from underneath. So obviously, as every time the source file will be attached with this video, but and I'm just gonna give you a preview of how this looks like. So I'll just scrub through this, and there you can see that it's sort of breaking apart in segments and not all at the same time. So you actually get to control what parts you want to break and what parts you do not want to break. Now, I'm just going to go over the source file for you guys quickly. So initially, and this is all like labeled and organized in a proper manner for you guys to understand. So the first part is to import the source geometry into Houdini. And because this was imported from Cinema 4D, the scale was quite massive. Uh, as you can see over here, like this is almost 13 units big, which is 13 meters if you convert it. But when I scale it down, it becomes a lot more reasonable. And once that was done, I sort of just moved on to doing some cleanup for this. Uh, in this segment where it says geometry deformation, I used a clean node to sort of get rid of any degenerate points or any bad polygons that I might have, and I just gave it a peak to, excuse me, to sort of, just inflate the plate a little bit. And I gave it some normals. And after that, I added a mountain node. Now, the reason I added this mountain node was because the animation when I was working on this, what I wanted to do was, so I wanted that sort of cylinder to break through and reveal this sort of deformed plate, and then this uh, then morphs into that refined plate. So I built the system around that. Obviously, I mean, you guys can choose to, skip this part. Now, after I had the mountain attached, I just remeshed it to sort of just get rid of some stretching and squeezing. I mean, you can see in when it comes to the chords, it's a little too messy. But when I remesh it, it cleans up. Not completely, but just almost. Uh, I use a smooth node to sort of get rid of um, any reversed normal polygons that were showing. Uh, Once that was done, what I ended up doing was I sort of started, creating the shell that was gonna cover this plate. And for that, I just took a simple tube without the end caps. I gave it a polyfill to cover the end caps. And what I then did was I just sort of create a group to select the edges of the caps. Now I know I could have created this group before the polyfill, but I mean it worked. So once that was done, I just used a polybevel node to sort of give it some more detail around the edges because I wanted it to have some chamfer. And after that, I used a standard match size node to just scale it down to the size of the plate. There you can see. Now it covers the plate. Now once that was done, I UV unwrapped my cylinder, and after that I just transformed it to scale it up a little bit more. I'll just show you the plate. And oops, not that, this one. All right. I just transform this to scale it up so I can give it a bit of a bleeding around the borders. And this is important because I really wanted to, shave off chunks of the shell instead of just strips. But again, if that's the look that you're going for, you can try and just control it via this transform over here. Now, once that was done, the next thing that was important for me to do was to take this shell that I created over here and I imported this deform plate and gave it a little bit of a peak just to make sure, because what I'm going to do over here is I'm going to subtract this plate from the shell. So it gives me a shell which is basically empty on the inside. So the reason that I gave the peak over here is so that there's no intersections when I put the actual plate inside, right? So I'll show you what I mean. Uh, there you go. So you see this because I am going to be using this deformed plate as a collider. So this little padding, as I say, gives me uh, a bit of room for my simulation to go on properly. Now, once I had, Boolean this, and I'll show you how it looks. If I just clip this, there you go. That is how it looks on the inside. Now, once that was done, I just gave it some normals, and after that, I gave it an RBD material fracture. Now, this is actually, you could theoretically do this with Voronoi fracture as well, but this RBD material fracture gives you more control over what parts to fracture, where it fractures. Also, it gives you some more chipping detail and just a lot more control, and you can actually have different layers of fracture in this. So it's a little computational heavy, but it gives you a lot more control. Once that was done, I just gave this whole uh, fractured shell a color and exported it. Okay, now this is the part where it sort of starts to make sense. But before that, the whole idea was to control the fracturing via a curve, right? And for that, what I did was I took a helix, a basic helix. I just gave it a radius ramp. I scaled it. Uh, I did not scale it. Okay, pardon for that. Uh, what I ended up doing was I just gave it a transform node just to make sure that I have control afterwards if I wanted to meddle with it. And I mirrored this, right? And the reason why I mirrored this was because I wanted my shell to fracture on the outside, sorry, to start fracturing on the top and on the bottom as well, right? So it sort of uh, it covers the whole plate, and the simulation sort of ends in time. Otherwise, it becomes a little too slow. That's primarily why I decided to mirror it, right? And right now this looks like some sort of a spring, but yeah. Once that was done, I ended up using a math size node again, and yeah, what that did was it had me cover the whole the plate, and once that was done, I just sort of transformed this, scaled it down a little to make sure it fits within the plate, right? Now, after that, to actually when it comes to RBD simulations, uh, controlling what part to fracture and when to time it is actually not that simple. And as far as I've seen on the internet, there's not a lot of people talking about it. So this was something that I had to find my way around with. And I mean, I'm sure there are other ways to do this, but this worked for me, and I'm sure it'll work for you too. So what I did was, uh, I actually imported my curve over here, right? And you could see the point count on this, and I used a resample node to sort of even out the points on the curve. And I gave this a color, a standard white color. And what I did after that was that I gave it a carve node. And what that did was it allowed me to animate this curve, right? You can see over here. Excuse me for that. And after that, what I ended up doing was I used an attribute transfer with color attribute with the color attribute to be transferred, and I transferred that color attribute from the spline onto my um, fractured shell, right? And if I play through this, you'll see it comes out looking something like this, right? Now this acts as a mask for which part to trigger to be simulated and which part stays still, right? Now, once that was done, because this was transferred on the point level, I sort of just used an attribute promote to transfer this to a primitive level, which sort of gave me a whole block being active or inactive, right? But still, this was right now, if you can see, this attribute is still a three float vector, right? Once that was done, what I did after that was I just simply, I'll come to this part again. Uh, I used a delete node, right? I used a group expression where I asked Houdini to select all the polygons which were not black, right? And I used a delete node to delete those polygons afterwards. And what that did was it sort of gave me this geometry where all of the primitives were actually getting deleted. Now, the reason I did not want to do this at point level was because if this was at point level and not primitive level, instead of each block being deleted, you'd see points being deleted, and that is not something that we want. Once that was done, I just converted this into VDBs. I used a VDB reshape to why doesn't that work to erode it to dilate it a little, and you'll know why I dilated this. And after that I just converted this in back into polygons. Now on the other side, what I did was I just deleted the color attribute that I created, and I used an assemble node to sort of pack all of these fragmented points into one single geometry to prepare this for simulation. And after that, I used an attribute wrangle node to create an integer attribute called active. Now, what this does is it tells the RBD solver to treat all of this plate as active. So it's either one or it's zero. So it's a very binary attribute. It's one and zero. There's no two, three, four, five, six, seven, eight, right? Now this tells the whole system that anything which is active is equal to 1 is going to be active in the simulation, is going to be simulated, and anything which is not active will not be simulated. And that is exactly the attribute that we're going to be using to make sure that we can control what parts are being simulated and what parts are not being simulated. Now, once that was done, what I ended up doing was I just created a simple group, and I used the VDB that I created earlier, and I just selected the points on this geometry, right? That is all that I did. And I used it as a bounding object points or vertices, right? And now I'll come to the part where I use the VDB reshape is to make sure that this does not intersect with the geometry. So it has a bit of a wiggle room to it. So it can actually encapsulate the whole geometry. After that, what I did was I used an attribute triangle, another attribute triangle. I gave it the group activated, the one that I created over here, and I told Houdini that anything which is inside that group is active is equal to zero. Now, what that does, it tells Houdini that anything that was inside this bounding box is not active, and anything which is outside of this bounding box is active, right? So this way we've used that mask that we created earlier to control our simulation. After that, I just gave it a solid red color and exported it. Now, Another thing that I did over here was that I used a curve velocity and I generated a force from the curve that I created over here. And all of this is just a standard method of how you uh, generate a force or a custom velocity from a curve inside of Houdini. And I'll link a tutorial in the description so you can go to that and you can understand how this works. But that is essentially what this is. I'll just show you an example of how this looks like, right? So you can see that this is a force, a custom force that is made to act on the RBD simulation, right? Now, once I had all of these things created, I just created a simple .NET, used a rigid body solver, imported my RBD packed object, and used a pop advect by volumes to import that velocity that I had created and act as a force on this object. And the reason I sort of colored this red was because if I just uh, yeah, if I just hide this, you'll see that I have a plate inside which is actually going to be used as a collider. So that is why, I colored it so I can see the difference between the two of them. Now, once that was done, right, uh, if I just play through my, oops, not over here, it's gonna take a lot of time. And if I just play through my simulation, this is what you get. There you go. Okay. Now, once this part was done, like once I had this fragmented part being simulated over time, uh, I actually did a little bit of tweaking afterwards as well. So first of all, because I use Cinema 4D and Octane to render all of this out, what I did was I just imported that curve and use an add node to extract the points and a retime to sort of, just delay this and copy to points to just give these 4 or 5 spheres along that curve. Now, what I used this for was to generate some smoke inside of Cinema 4D for my final render. So anywhere that this plate was breaking from or this tube was cracking from, there'd be sort of those debris and smoke, right? Now, talking about debris, what I ended up doing was I imported my DOP simulation over here and I just used this DOP to blast or split the plate from the inside, right? And once that was done, I used a debris source node to scatter points onto my fractured geometry, and I used a delete node to delete all the points that did not have an edge, and I filtered it further to delete all of the points that were sort of the age of whose points was greater than zero point 0.1. And I imported that into a popnet, right? And what that did was uh, it gave me a simulation where, let me just play this. Oops, not there. I was supposed to play my popnet cache. Yeah, what that did was it gave me a simulated particle source that was actually emitting along with my DOP, right? And what this enabled me to do was create secondary smaller particles so that I can add more detail into my whole simulation, right? And this was very much about it when it came to this specific problem. Let me know what you guys think, and I would be happy to answer any questions that you guys might have. Thank you. Cheers. Bye bye.